Welcome back. Today we're going to talk a little bit more about solving log and exponential equations. So you remember last time we talked about this method of rewriting the equation, either taking it from exponential form and turning it into log form, or going the other way. So let's review that real quick. So here's an example where we want to solve for x. We're told 10 to the x equals 50. And so what I'm going to do is I'm going to rewrite this in log form. So I'm going to take log base 10 of 50 equals x. Okay, so I'm basically just following this rule here that if you have something written like that, it's the same thing as that. And so I'm just rewriting it using logs. And what that does is it tells me that x equals log base 10 of 50. Now, you probably don't have memorized in your head what log base 10 of 50 is, but we can type that in a calculator and see what it comes out to be. I believe it's about 1.698 or something like that. I only have it memorized because we've talked about it so much in the last couple of days, but you can just grab a calculator and type it in. So for this problem, we want to kind of do the same thing, but you'll see that we're a little stuck because we have this divide 2 over on this side. So we're going to have to do something to fix this before I can apply my strategy of rewriting it as a log. And one maybe obvious thing to do is you can multiply both sides by 2, and that will cancel out this division going on over here that's messing things up, and you'll be left with 10 to the x equals, well, 40 times 2, that's 80. And then from there, I'm able to rewrite it using my logs. So I can say this is log base 10 of 80 equals x. And that I can just type in my calculator and figure out. I think that ends up being 1.903 or something like that. But the idea here, we're trying to get this 10 to the x by itself so that it's equal to a number, and then I'm able to rearrange stuff into my log format. Okay, so basically just doing things to get 10 to the x by itself. So here's another example we're going to try. It's got a little more going on here, but basically the strategy is the same. We're going to try and get this 5 to the x by itself so that I can use my logs to rewrite it. Okay, so what do I have to do to get 5 to the x by itself? Well, first I got to get rid of this subtract 20 that we're doing and this times 16 that we're doing. And remember, when you're undoing stuff, you have to do it in reverse order of your order of operations. Okay, so add and subtract is the last thing we do when we're calculating something. It's the first thing we need to undo when we're going backwards. So we're going to undo this subtract 20 by adding 20 to both sides. Okay, so that's going to undo that. And we'll get 16 times 5 to the x is equal to 60 plus 20 is 80. Okay, and now that I've done that, I can successfully get rid of this times 16 by dividing both sides by 16. So I'm just going to divide both sides by 16 here, and that will cancel out over here with the times 16, and we will get 5x by itself is equal to 80 divided by 16, which is 5. You can use a calculator if you want to calculate that, but I just happen to know that it's 5. And so now I'm able to write this in log form. Log base 5 of 5 is equal to x. Now log base 5 of 5, log of any base of the base. Now log base 5 of 5 is equal to 1, because how many times do you multiply by 5 to get 5? And do it one time, or 5 to the first power is 5. So x is going to equal 1. So again, our strategy here was to take this equation and just kind of get rid of stuff by using inverses until we were left with just a single exponent equals a number, which we can then rewrite as a log and calculate. Okay, this idea of preparing the equation like that works going the other way too. We can get the logs by itself and rewrite it as an exponent, and it'll work just as good. So in this equation, we want to get the log base 3 of x by itself. So I'm going to get rid of the add 7 and the times 2. So first I'm going to subtract 7 from both sides. And that will leave me with 2 times log base 3 of x. Sorry, my parentheses don't show up too good when I use my mouse. And that is going to equal 11 minus 7. That comes out to be 4. Okay, now the next step, I want to get rid of this times 2. So I'm going to divide both sides by 2. Okay, and that will cancel over here. The times 2 and the divide by 2. And 4 divided by 2 will come out to be just a 2. And so that will equal log base 3 of x. Okay, and now I can rewrite this as an exponent. So I can basically apply this rule going the other direction now and take something that looks like this on the right and make it look like this on the left. So let's go ahead and do that. So that'd be 3 squared equals x. And I know 3 squared is 9, so don't need a calculator for that. X comes out to equal 9. So the main strategy we've been doing here is basically preparing the equation to apply this rule. So we're simplifying the equation to the point where we're able to use this principle to rewrite it and get our answer. Now, another thing we might come across is equations that we have to do some work after we've applied this rule. So we're going to call that processing the equation. So that's when we have to simplify the equation after we've rewritten it to see what x equals. And here's our first example. So we have 10 to the x plus 2 equals 50. Now it's already written in the form as something like b to the n equals m. Okay, let's highlight these so we can see. So we have b here, which is like our 10. Okay, and then we got our n, which in this case is x plus 2. So that's a little weird, right? It's not just one thing, but it's an entire expression. Okay, and then we have our m, which is going to be our 50. So I can rewrite this using logs as log base 10 of 50 equals x plus 2. Okay, and now you're seeing the problem that we were anticipating, right? Is we don't have x by itself. We have x plus 2 over here, and it's equal to log base 10 of 50. So I'm going to have to do some work to get x by itself, which isn't a big deal here, right? All I have to do is subtract both sides by 2. Now be careful when you do that over here, right? So we're not taking 2 from 50, we're taking 2 from log base 10 of 50, which we said earlier is 1.699, right? So we're subtracting 2 from that, okay? What I like to do though, instead of rounding, because sometimes that gives you more error than you would like, we're just going to type it as log base 10 of 50. Just make sure we're saying that 50 is the only thing in there, and then subtract 2 from whatever that is. Now over here we've added 2 and subtracted 2, so x plus 2 minus 2 is going to be just x. So those are gone. And we have x equals this, log base 10 of 50 minus 2. And you can type that in your calculator as is, and it'll tell you what your answer is. Let's go ahead and do that real quick. Okay, so here we are. Okay, so log base 10 of 50 minus 2. And the answer turns out to be this decimal right here. We can just round it to 3 decimal places, it said. So negative 0.301 would be the answer that we put in. Okay, so we have x is equal to negative 0.301 rounded to 3 decimal places. So here's one last example. We're going to take log base 3 of 5x plus 1 equals 4 and rewrite that in exponential form. So 3 to the 4th power equals 5x plus 1. So again, I'm just taking this from this form and converting it into this form. Okay. And once I've done that, instead of having x by itself, like I did on the first couple of problems, I have an expression with x in it that I need to work at to get x by itself. So I'm going to subtract 1 from both sides. Okay, and again, remember, we're not taking 1 from 3, we're taking 1 from 3 to the 4th. Okay, now we could say 3 to the 4th, that's 3 times 3 times 3 times 3, I believe that's 81. Okay, so if you wanted to, you could say this is 81 minus 1, which is just going to be 80. Okay, equal to 5x. Or if you weren't sure, like maybe you have some decimal up here and you're not sure exactly what that equals, you could just put 3 to the 4th minus 1 is equal to 5x. Okay, doesn't really matter. It's the same thing. 3 to the 4th minus 1 is 80. If you type it in your calculator, you can see that. Okay, but the next step here is to get rid of that 5. I'm going to do that by dividing 5 since I'm multiplying by 5. And I have to do that to both sides. Okay, and so we have x equals 3 to the 4th power minus 1 divided by 5. Okay, and keep in mind we have to do this first, then divide by 5. So you could type that in a calculator. Like we said, we already know that 3 to the 4th is 81. Minus 1 from that, you get 80. And 80 divided by 5 is 16. So this equals 16 right here. Sometimes you'll get stuff that you can do in your head. Sometimes you'll get stuff that requires a calculator. The bottom line is we got our goal that x is 16. So I've solved this equation like it asked me to, and I figured out what x is. So to recap, we did some examples where we have to prepare the equation before we can rewrite it. And then we looked at some equations where we were able to rewrite it, but then we had to do some stuff afterwards to get x by itself. It is possible that you might come across some equations where you have to do both. You might have to prepare it a little bit before you can apply the rule. And then once you've applied the rule, you might have some more work to do to get x by itself. But you get the general idea. With some practice, you'll get really good at doing it. If you have any questions, as always, give me an email, let me know, and make sure you tune in next time for the next lesson.